This problem say you have two charges, Q1 and Q2. You have an electron here. So the two charges produce an electrical field here at the point P. It will produce an electrical field, and it will produce a force that will go directly going up. The acceleration is going in this direction, so the force is going the force always follow the acceleration, so the force is going also in this direction. So I need first to imagine what force will produce an acceleration in this direction, and the only possibility that I can find, for example, will be like this. This is due to the symmetry. This is, let's say, A, and V, and the point P. So I need a force that will end it in this direction. The total force will end in this direction. I think that I did incorrectly the problem at the class. The total force, it will go in this direction, but this is an electron. So the electrical field should go in this direction. The total electrical field will go in this direction. So, so the question is, it should go in the opposite direction because the force is Q by E. So if E is negative, the force will go up if the electrical field is going negative, because something negative multiplied by the charge that is negative will make the force positive. So this is the result. So, sorry, I think that I made a mistake during the class. So, what charge produces an electrical field like this? Well, if I put a positive charge here, it would produce an electrical field like this. If I put a negative charge here, it will produce an electrical field like this. And the total electrical field will be the sum. So it will be the sum, will be this E, the total E. And the force will be Q by E. So what I need to have is one positive charge here and one negative charge, and I need the same amount of charge. So if this is Q positive and this is Q negative, what I want is that the magnitude of the Q positive will be equal to the magnitude of Q negative. Do I need this? Yes, to produce this. So the total electrical field, it will be this magnitude. So it means that this component of the electrical field produced by the negative charge will cancel with this component of the electrical field produced by the positive charge. It will cancel and will go only, electrical field will go in this direction. So I will find first the total electrical field, this one. The magnitude of this electrical field will be the magnitude of one of them that are the same by this angle that I'm going to call alpha, by the cosine of this angle. But the total electric, 2 times this will be the total electrical field. One is the projection of the negative charge, the other is the projection of the other electrical field. So the magnitude of E1 will be 2 times the magnitude of Q1. The magnitude of Q1 is K, Q positive or Q negative, doesn't matter, divided by D squared. D squared is A squared plus V squared. Okay, D squared, A squared plus V squared. By the cosine of alpha. The cosine of this angle, you can see here, this is B, and this is A. The cosine of the angle alpha is A divided by the hypotenuse. The hypotenuse is a squared plus b squared 1/2. So I have found the magnitude of E. And the force is the charge of the electron, Q of the electron, by the electrical field. And the force, of course, will go up. So the magnitude of the force will be Q of the electron, 1.6 by 10 to the minus 19, by the electrical field, by the magnitude of the electrical field. So this is the force. So the magnitude of the force will be the charge Q by the magnitude of the electrical field. Okay, so I put it the magnitude of Q, I will obtain the magnitude of the force that is going up. So it's Q of the electron, and the value of E is 2K, a Q positive or negative, because I have placed Q positive equal Q negative equal Q, divide by A squared plus B squared, 3.5, by A. Okay, this is the magnitude of the force. And the magnitude of the force, this magnitude, is, I am not lucky to choose this A, this distance A. Let's go to call it this distance. Instead of A and V, A I'm going to call it D1, and B I'm going to call it D2, and the hypotenuse, so this is the charge. I don't remember how positive and negative. Let me see, yes, positive and negative. So this is the charge. I have called this D1. I have named this distance D2. I have named this distance D. Sorry. So the magnitude of the force is the charge, the electron that is placed at the point P, where the electrical field is E, and the total electrical field at the point P is 2 times K, Q divided by D1 squared plus D2 squared multiplied by D1. Okay, we are clear, multiply by this distance, that is, it's A, is B, is D2, by D2, okay? D2, okay, let me, sorry, D1, I call it D1, sorry, D1, okay. So this is the magnitude of the force, so the magnitude of the force equal to the mass by the acceleration, the magnitude of the acceleration. The mass of what? The mass of the particle that is at the point P is the mass of the electron. So what it's asking us is now is the charge. It's asking the problem. So the charge Q will be the mass of the electron by the magnitude of the acceleration of the electron. Multiply, this is 3.5, okay? Multiply by D1 squared plus D2 squared, 3.5, okay? Divide by 2K, D1. This is the charge Q that produce this kind of electrical field. So let's say that this is 3 coulombs. It means that the composition is that you have a negative charge down, you have a negative charge here of minus 3 coulombs, you have a positive charge here plus 3 coulombs. This is A and B. Let me see how I wrote it, A and B. This is A, and this is B, and this is the point P of observation. So the positive, the negative charge, perfect. And the value of the charge, if the result that plug in numbers, all the numbers are in the problem, the mass of the electron, the A sub I, this distance D1, this distance D2, this 2K, K9 by 10, and D1, if you plug in numbers and you obtain that this is 3 coulombs, it means that the other charge, this one is minus 3 coulombs, and the was is 3 coulombs, and the problem is done. How to find what is the correct answer here? I don't know. You have to do it. Okay.